Okay, let's continue looking at derivatives. So to remind us of the derivative formula, the derivative of x to the n is equal to nx to the n minus 1. So for finding the derivative of y with respect to the variable x, this first one, what do we get here? Yes.
15x to the power of 4
15x to the power of 4 minus
4x.
minus 4x. Excellent, yes. Excellent. So this second one, we need to rewrite it into index form. When the term in the denominator moves up, the exponent becomes negative. So the derivative with respect of y with respect to x, so this one is going to be what? Really? Not quite. The 5, if you notice, has no x in it. So this is a constant term. And when you differentiate a constant term, it disappears. See, because you get a line like this one. This is the line y equals 5. Now, what is the value of y here at this point? What is the value of y here at this point? What is the value of y here at this point? The value of y doesn't change. The derivative talks about how the function changes. The derivative talks about gradient. So if the function doesn't change, what is the gradient? What is the amount of change? 0. And this is why when you differentiate a constant term, it disappears because it becomes 0. The derivative talks about the rate at which the function is changing. Now that part of the function never changes. So the derivative of that part of the function is 0. So there's no change. So this one becomes a 0. Right, let me see if you got the second bit right. This one's going to become, exactly, this one's going to become 4x to the minus 2, which as you rightly said is 4 over x squared. How about 6? Who's going to help me with 6? So, Lorenzo. Sorry, let me write. Derivative of y with respect to the variable x gives 8x
minus 6 over x.
Ooh, sorry. Let me, for clarity, rewrite this one as like that. Okay, now
Yeah, minus 6 over x.
Minus 6x to the minus 3, which you rearrange to minus 6 over x cubed. Okay, excellent. This is your basic derivative formula. Your typical derivative would be like these 5 or 6. You're going to get one of these with a rational function in it. We're going to look at finding tangents and normals. So I've put this on the slideshow for you for today on the Google Classroom. You can have a copy it down a bit later. But it's the basic process of finding a tangent or a normal. This is a very common procedure. So to find a tangent or a normal, what are we talking about? What are we talking about? What we're talking about is if we have a function like this one, if we have a function given to us like this one, sometimes we want to investigate the properties of that function. We want to find its value. We want to find when it's 0. We want to find what its value is when it's 0. We want to look at the domain. We want to understand the functions. It describes and models a real characteristic. So the derivative is an extra piece of information. The derivative tells us how the function is changing at any point on the curve. So one of the basic exercises to learn to use the derivative is to practice playing with tangent and normal lines. Now a tangent line, we take any particular point. Let's take this point here where x is equal to 2. Let's take this point here where x is equal to 2. We can find the value of the function. We can also, we might be interested in how is the function changing. Is it going up or going down at that point? It's going down at that point. So the derivative will tell us the rate at which it's going down. That's what the derivative tells us. Now, one thing we need to draw is we can draw a tangent line. So a tangent line is a very special line which comes down. It's a straight line and it touches the curve at one point and one point only. This is the verb to tangent. So if the line tangents the function at x equal 2, then they will have the same gradient at that point. This is the characteristic of a tangent line. The derivative and the function, the gradient of the function and the gradient of the tangent line are exactly the same. So the derivative, not only will it tell us the gradient of the curve at that point, it will tell us what gradient to use for the tangent line. So in the process for finding a tangent line, step number 1 is to find the derivative of the function. This will give us the derivative of the blue line. It will tell us the gradient of that line at any point. So using that, we would find the value of the derivative at the given point, for instance, like at 2. So this would be this thing. The derivative f dash of a, for x equal to a, will give us the gradient of the blue line at that point, x equal to a. It will give us the gradient of the tangent line at that point. If we're finding the normal, we have to do one more step further. We take find the gradient of the normal, we take the gradient of the tangent line, which is the one we've just found here, and we take minus 1 over this, and this will give us the gradient of the normal at any point. Because the normal is perpendicular to the tangent at this point. It's about perpendicular lines. This is a perpendicular. Normals are useful for, let's say you have two curves passing through space. Just to give an example, why do we want a normal? Let's say we have two curves passing through space like this, and we wish to find the shortest distance between these two curves. It's a difficult problem. Now, the shortest distance between them is a journey along the normal. So you need to find the normal at one particular point, and the shortest distance will be along the normal. That's usually how those type of problems play out. We don't do problems of that complexity on this course. We do find normals and tangents. So once you've found the gradient of the straight line you're trying to find, you then have to find a coordinate. So in that diagram, we can only see that x is equal to 2. We can't see the exact point it passes through. So we need to find the y value at this point. We need to find the y value at this point. So that's step 3. So step 3 is to find the y value. We do that using f of x. You put an x value into f of x, and it will tell you the value of the function at that point. The tangent, because they tangent at this point, shares that point with the function. So it's the only point it shares with the function. We need to find the y value, we need to find the gradient. Lastly, it gets easy at that point. Step 4 is you've got your gradient, you've got your point, and you put those into point slope form, and you've got your tangent or normal line. The last step in some of your IB questions is to rearrange it into the form given. So this is the equation in point slope form. It might often say, given in the form ax plus by plus c is equal to 0, where a, b, and c are integer. Often says that one. There's another slide I wanted to show here at this point. Here, yeah. So this is something that students get confused with quite a bit. F of x tells us the value of the function any value. It tells us the y value at any point. The derivative tells us the gradient of the function at any point. And this is one of the tricky things when you're first learning to use the derivative is, do I want f of x or do I want f prime of x? This is a common difficulty that you have to get your head around and sort of start to understand. Let's try an example problem. Let's do this one together. Step through the steps, nice and slowly together. We've got the function here, f of x is equal to a half x squared plus x. Step 1 is to find the derivative. So have a go at that for yourself. How do we find the derivative? What did you get for the derivative?
X plus 1.
X plus 1. Super easy, eh, that one? Next, we need to, if we look through our thing, we need to find f dash of a at x equals a. So we need to find the gradient at our point we're interested in. Our point is x equals 1. So we now need the gradient of our tangent line is going to be f prime of 1. So that's going to be 1 plus 1. Can anyone help me with this one? 2. So what is 2? Of what? M is a gradient. The gradient of what? The gradient of the function at this x equal 1. What else is it?
Tangent.
The gradient of the tangent at any value. So what we've got here is that blue line, well, upside down here would be, it'd be 2, the gradient of the blue line, and the tangent would be 2. So this, where am I going? This problem here we've got something that looks like this. We've got our tangent line over here, it's going up, here at x equal to 1. This is what we've got so far. So once we've got the gradient, we also need to find the y value. So we need to do step 3, find the coordinate of the point of where the tangent touches the curve. We need f of a. So we need to find y, which is f of 1. If we put it into the function, we're going to get a half 1 squared plus 1, which is 3 over 2 or 1.5, whichever you prefer. So we've got that. What we're going to do last is we're going to insert it and create the tangent line. So we stick it into the function using the formula. The formula is y minus y1 equals m bracket x minus x1. This is the point slope form of a straight line. It's the easiest form of a straight. When you're creating an equation for a straight line, it's much better to use this than to use mx plus b. Using point slope form, y equals mx plus b, it's very useful when you're reading off a graph. That's the best one. When you're reading a graph, go to y equals mx plus b. When you're playing with points and coordinates, go to point slope form. So go to, point slope form. It's easiest for this type of problem. So let's put our values in. Our y value we got was 3 over 2. Our gradient we got was 2. And our x value is 1. So this is the equation of the tangent line. Very often they'll ask you to give it in the form of ax plus by plus c equals 0, where a, b, and c are integers. So if you have a problem like that and you have any fractions in it, you want to start by removing the denominator. So we can remove this denominator by multiplying 3 by 2, because you can't have fractions. This will give us 2y minus 3 equals 4 bracket x minus 1. So notice I've taken this 2 and I've multiplied it onto the other 2 terms. Read it through, make sure you understand it. Now I'm going to open the bracket. We get 2y minus 3 equals 4x minus 1. And then I can rearrange it into 2y minus 4x minus 2 equals 0. And we've got it in the standard form. I usually like to write the x at the front, make it positive. 4x minus 2y plus 2 equals 0. Both are acceptable, as long as it's integer multiples. So you notice here, you'll get this one right because it's an integer multiple, but all of those can be divided by 2. So we can have this as 2x minus y plus 1 equals 0. It's the same line. This is simplest possible form. Okay, let's have a go at the problem. Have a go at this one for yourself. I'll pause the video. You can have 5 minutes. This is your typical exam question. Okay, can anyone help me with the derivative to begin with? What's the derivative, Kenneth?
3x to the power of 2 over 6 plus 2x.
3x to the power of 2 over 6 plus
2x.
plus 2x.
And then simplify it to be half plus 2x. Half x to the power of 2 plus 2x. Lift out.
So we get a half x squared plus 2x. Is the simplest. Okay, what's the gradient? So the gradient of the tangent line is going to be f prime of 1. That's going to give us 2.5 or 5 over 2.
So how do we do it?
Oh, sorry, let me. No. How do we do that? So I'm saying it's 5 over 2. Often the question asks that we show the derivative, but you don't always have to use it to get this value. We can use the calculator. Get your calculator in your hand. Get your calculator in your hand. I'm just going to start a new document. Let's add a graph. I'm using it at the moment. So I'm trying to get all my calculators charged. I'm going to start off by drawing the function. So type in the function x cubed equals 6 plus x squared plus 1. Our function looks like this. Our line is this. We're going for a normal line. It's going to be here. There. Type your function. There's a few bits and pieces we can do. I'm going to show you a few techniques with the calculator. Do you have it typed in? Do you guys have a calculator that works?
My battery, like the battery is frozen.
Okay, so what are you going to do about that? Lesson after lesson?
I ordered a battery that's going back to it.
Okay.
You talk about ourselves.
Yeah,
Well, I
said that a month ago.
Can I go?
Okay, so go back to the calculator screen.
Sir, I got a completely different slope. Mine is funky.
You see? Yeah, you squared it, not you're graphing the derivative. You're not graphing the function. This is the function.
Now,
So if we've got the derivative the function typed in there, press menu, and then calculus, numerical derivative at a point. We want the derivative of x. We want it when x is equal to 1. So we want 1, we want the first derivative. We get this little feature. We can press variables. There's our function. It's f1 of x, like this. And there's our answer.
so you put that wrong here, my calculator.
Sorry. Yeah, because you're in the scratch pad. I say again and again, I never use the scratch pad. I always press on, new document. Oh, you've got this one entered here. So you started in the right place, but then you went to the scratch pad. How to calculate it. Now it works. This is 2.5. You want it as a fraction. So menu 2 turns it into a fraction. Other ways to calculate it. Over here, we can calculate it here as well. Analyze graph, find the derivative at any position. We want to type in 1, 2.5. Yeah, the other one, it is a useful technique for more advanced skills as well. I'm showing both of these because they're both good skills. There is even geometry, points and lines, tangent line, number 8. We want the tangent at x equal to 1, so here. Look, there's the answer. That's the equation that we're after for a tangent line. Look, which bit?
To get to the tangent of the slope.
The menu, analyze graph number 6. 5, so type in 1 on your keyboard, press enter. Okay, don't just see one technique that I show and say, oh, that's the easiest, I'll learn that technique. Those are all the techniques. There's a couple of techniques in there. I show a few for a different reason. All right, so coming back to our problem, we've got the gradient of the tangent. But do we want the tangent or do we want the normal? We want the normal. Look at the question. We want the perpendicular. This means we want the normal. So this implies that the gradient of the normal is equal to minus 2 over 5. The negative reciprocal. The negative reciprocal, correct? Perpendicular.
Isn't that for C? Oh, no,
So next up, we need to find the value of y. The value of y is f of 1. Take care at this point. Where are you putting the 1? You're putting it into the original function. The original function gives us the y value. The derivative gives us the gradient value, the m. So we want the original y value. We put it into this. We get 1 over 6 plus 1 plus 1. Turn this expression into a fraction using your calculator. Turn this expression into a fraction using your calculator. Try that now. Okay.
I'm good on B. Why did you do 2.5 and then you negative 2.5?
Sorry?
For B, okay, the slope of the tangent line. We first go 5 over 2. I don't understand why we have to flip it and do negative 2 over 5.
Because the derivative gives us the slope of a tangent line. It doesn't give us the slope of the normal. And this question is asking for a perpendicular.
It didn't say, it said perpendicular in question 3.
That's where yeah, so I've done this, that's there. I've done this, that's there. Now I'm doing this. They're not really labeled A, B, and C, so I'm just doing everything it asks me. I see what you mean. I should have done this on the next line to show more clearly that I'm starting a new
Yeah,
point.
okay, so the answer for B is 5, it's 2.5.
Yeah.
Yeah, okay.
Yeah.
So you don't have to do 13 over 6.
Oh yes, I'm like, what are you talking about? 13 over 6, excellent. Excellent. So we're after our straight line equation, so we stick this into y equals y minus y1, so y minus y1, and then we need our gradient, x minus, and our x value is 1. We've got to turn this into integer values. This is a hard problem. There's lots of numbers here and there's no common denominator and things. We've got to get rid of the 6 and the 5. Yes, I do want to take that here down. Maybe get a bit more attention. So what do we have to multiply through by to get rid of the denominators?
You could multiply by 30.
Why would we multiply by 30?
Because it's the lowest common denominator.
the lowest common denominator. So we're going to get a 30 here. What does this term become? It's going to be 5 times 13, isn't it? When we multiply by 30, the 6 cancels in the 30, and the 30 is like 30 divided by 6 becomes 5. So 5 times 13, what's that? 65?
Yeah.
65, you can use your calculator. Oh, 65. This minus 2 over 5, if we times it by 30, what does it become? It's 6 times minus 2, negative 12. So we get negative 12x, and then negative 12 times negative 1 plus 12. Let's rearrange everything. We get 12x, bring that across. We've got 30y, and we bring this across, minus 77 equals 0. These numbers in this format have to be integers. So when you have that format, you have to turn them into integers.
I'm good.
Sorry?
I'm good.
Which bit?
Why you have to multiply by 30?
We have 2 denominators, a 6 and a 5 that we have to get rid of.
Yeah.
So 6 times 5? 30. So if we times by 30, these 2 numbers will cancel. You can do it in 2 steps if you want. You can times by 5 and then you can times by 6.
No, I don't want to get confused. We go from 1 over 6 plus 1 plus 1 equals 13 over 6. And then we jump down. I don't know how we got these numbers.
You've got to come on time. You've got to come to class on time. So I went through this at the beginning half of the class, which you missed. It's the standard form for a straight line equation like this one.
Oh yeah, I wrote that down.
Okay? It's the standard form for a straight line equation. So we've got y minus y1 equals n bracket x minus x1. Then when we multiply through by 30, you can do some of this multiplication if you want using your calculator. So I got this 65. You know, for some people that can be a bit daunting, but you've always got your calculator on hand. So in effect, when you're getting, what you're doing here at this point, here, to get to there, is I've got minus 13 over 6. Let me do it as a fraction. Minus 13 over 6 times 30. So just do the numbers if you want using your calculator to support you a little bit. We get minus 65. So you can do these little bits and pieces which might seem a little challenging and confusing using your calculator. Just take the number out and just multiply that without using the letters. Let's try a different type of problem. So this was revision from last year. Our revision for today. So we're doing the derivative formula in our calculus review. This is the derivative formula. Remember that the function f of x tells us the value of the function any x, whereas the derivative tells us the gradient or slope of the function of f for any x. We've done some practice on that. We've done some practice on that. Have a go. This is an exam style question. Have a go at this exam style question for yourself. Do you need charging?
I'm so sorry.
Not late, it's missed class.
They just coded me, so I have to go back home and then.
much as possible to help me with this one. So let's pull up the calculator, sketch the curve here. You see the graph drawn there. So firstly, we have to find the expression for the derivative. We can't use the calculator for this one. So for A, we've got f of x is equal to x minus 2x cubed. This means that f prime of x is going to be equal to 1 minus 6x squared. You have to use the formula for this one. The rest we can do on the calculator. So for B, I need to find the derivative at x equals 1.5. I'm going to do it here. I'm going to press menu, calculus, derivative at a point. Our derivative value is going to be menu, calculus, my smartphone went a bit funny, is 1.5. And our function is f1 and then of x.
So why don't you do the easy one?
I want to show you more than one technique so that you can do more than one type of problem. So we move across here. Here at this point, we need to now find for C, we need to find the y value, or y1. This is given by f of 1.5. So f of 1.5 we can get here, we press menu, trace graph, and we can type 1.5, press enter twice, and it gives us the point down here. 1.5 comma 2 minus 2.25. We can do that here as well. Press variables, pull up the function, type in 1.5. So this is equal to minus 5.25. We have all the information we need. We put it into our point slope form, but you probably want to convert these into fractions, because if we're going to go for the ax plus by form, fractions is easier because you have to make them whole numbers. So this one I'm going to do menu number approximate to fraction. That means minus 21, and this one menu 2 minus 25. So we have y minus negative 21 over 4. So the gradient is, let me just type this in, let me focus so I don't make a mistake.
Isn't our y 5.25? Negative 5.25?
Yeah, so negative 21 over 4.
That's our y, right?
Yeah, but it's y minus y1. So it's minus negative. In the same way that this is, our x is 1.5, which is why we have subtract 1.5. Here we would subtract negative 21 over 4. So the minus and the minus cancel becomes positive. So I'm going to times through by 4 now. This will give me 4y plus 21. Here was going to give me minus 50x. And then minus 50 times this is going to give me plus 75. You can do this on the calculator if you want. Minus 25 over 2 times minus 3 over 2. Do this on the calculator if you want. Rearranging it, I get 50x plus 4y. I'm going to do that one. 21 minus 75 minus 54. Minus 54 equals 0. This is your very typical simple basic derivative question that you'll experience on your exams. One thing that makes it a little bit harder is we have just been doing tangent line problems today so far. When you come to your mock, we're at the end of the course now, so when you come to your mock, you're going to get thrown a bunch of different questions. So you have to sort of distinguish between them. So for our calculus review today, we're going to look at this problem next. Have a read through this one. Sorry?
Would this be one of the harder questions?
This is paper one. These are still, this is, I think paper two questions are harder because they have multiple steps. You can sort of get quite involved with it. This type of question I would say would be medium hard. Yes, Jeff?
So do you have like a practice book?
No, the booklet,
No.
the booklet I handed out, that's the practice mock. It won't be, that's how it's gonna look. That's the practice for the mock and for the final.
So the whole thing is going to be the honor question of the exam?
Yeah,
Like the whole booklet?
yeah, you're gonna be there 12 hours. It's separated into different papers. You can find paper ones and paper twos. You have one paper one, one paper two. These are paper one style questions. These are paper one. Paper one, it's only the last three questions that usually get tough. The first half of the, well, there's usually about 12 questions. Questions 1 to 9, they get steadily harder as you go through it. This one would come around about, feels like about a 9 or a 10 out of the 12 for me. The one we just did would be like a 3 or a 4. Okay, we're going to do this one together. We don't have much time. So, a company produces and sells bicycles. The company's profit P in dollars changes based on the number of bicycles they produce per month. So, the rate of change of their profit from producing X electric cars is modeled by this function. Notice we're given a derivative. Notice we're given a derivative. What does the function P describe?
The original.
What is the original function? What is the original function talking about?
The amount of profit.
Profit. So here in the question, the company's profit P. That's not this function. That's not this function. This is the derivative. This is the rate at which the profit is changing. What does X represent? X represents the number of electric cars. So how many electric cars? How many electric cars? So the company makes 230 profit when they produce 10 bicycles. So notice here at this point, we've got this. This means that there is a point 10, 230. This 230 here is a P. This is an X, P. This is an X, P. The company makes a profit. P is the profit. This is the derivative. Find an expression for P in terms of X. So this is a typical question. It's one of the harder type questions. It's an integration question. I think you had one like this on your semester exam. What we need to do for this one is you need to find the original function given the derivative. So we start off by integrating. We've got to find the integral of minus 0.24x plus 18 with respect to the variable x.
Isn't that minus 0.12, that's 3 plus 18x?
Let me do it in an extra step. I want to show the extra step. So use the integral formula. You can find that on the back page of the formula booklet. It's the second formula, I think. Yeah, the second formula on the formula booklet on the back page. Take a look at it now. Take a look at it. Remind yourself of it. So what Yatsan says, he simplified it, but he's going to go for this. This goes to 2. This goes over 2 plus 18x plus c. And he gave me it in this form. So p is equal to minus 0.12x squared plus 18x plus c. What is the value of C?
Any,
Not in this question. We have to find it. So this type of question, the main thing that we have to do is we integrate it, and then we have to find the value of C. How can we find the value of C? Plug in the point. Somewhere in the question, in the wording, there's a point that's been given to you. They'll hide it in the wording. Look for the units to really help you. Look, this is 230. That's the units of money, profit. This is the number of bicycles. This is an X. This is a P. DPDX would have the units of bicycles per month. So a value for this, the derivative would be bicycles, the unit would be bicycles per month, because it's profit, sorry, dollars per bicycle. What am I saying, bicycles per month? A unit here would be dollars per bicycle. So this would be dollars. So plug it in and see if you can calculate the value of C. Hey. They're having a go at something. Yes. Sorry, let me. So we put in our numbers. We've got 230 is equal to 0.12, and then 10 squared is 18 bracket 10 plus C, and then n solve. What did you get for C? 2,132. Did you get that, Lorenzo?
No, but I think I did it wrong.
oh, yeah, I did it wrong.
Let me do it, and I'll try and do it right. And we can compare.
I got 1250.
That's 62.
62. So, our function p of x is minus 0.12x squared plus 18x plus 62. 5 marks. That's pretty easy for 5 marks. Find the profit made when the function is set to 50. Super easy. So a question like this, let's say you have a stab at the first bit and you can't get it right, write a function so that you can always pick up this type of a question. You'll get follow-through marks. So if you have no clue how to do it, write any old function down. Say p is equal, well, make it look like that one. Make it look like that one. Add something to it, and then just put a number in. You've got a really good chance of getting 2 follow-through marks. I saw this on the semester exam in my other class. They had a problem where they had to find a straight line, a tangent line, and they just couldn't find the tangent line. But the next one was to find the distance from the point to the tangent line. So they just made something up, and then there you go. All right. So we need to put 50 into our function. We need p of 50. Let's try that on the calculator straight away. Minus 0.12 times 50 squared. 50 squared. Plus 18 times 50 plus 62. Ooh, what do we do with that number? Ooh. What is this?
10 to the power, or the times 10 or something.
Times 10?
Yeah.
So minus 2.9 times 10 to the 4, which is minus 2, 9, 1, 2, 3, 4. Find the profit when the production is set to 50 bicycles per month. It's very, very small.
If we do sparks if we left the AISL 2.9 times.
So I got
If you would, unless you put in a zero there, because it's cutting it, it needs to be three significant figures. Now I would get it. Let's just see how we can make the calculator stop doing that. Because the calculator is in three significant figures. So if I go to the settings, and I go back to don't give me three significant figures, what does it give me?
So did you mean to put?
I think I made something wrong.
Did you mean to put 12 instead of 0.12?
Did not.
Yeah.
That's why.
Because I got 662, which is
That sounds much better.
a slightly different number. Okay.
All right, cheers. But still, it was interesting to look at the standard form. So we're getting 662 for our profit. Here on this one, with that wrong answer, can I just show you, with that wrong answer, I would have got no points. But if I had done this, and then written the wrong answer, then I'd get 1 point for showing the method. For showing the method. So if I showed the method here, what's really important is remember I said if you got the equation wrong here, you'll still get follow-through points. Only if you show the method. So if you got the equation wrong there and then you put an answer here, answer only, you get no points. You get the equation wrong here, you show the method like this, and then you calculate it, you can get up to 2 points. But if you don't show a method with follow-through, you don't get follow-through. So make sure you show your methods, because you never know when you're going to be wrong in order to get the follow-through marks. Bye-bye.
Right, class.